In this second video, we will go over the experimental procedure and required data analyses for the lab report. As the first step, place 350 cc's of water in your container a bit at a time. Add bentonite a bit at a time to the water. Prepare 8 samples using the various amounts of bentonite values shown in Table 1. You need to prepare a new mud each time and mix for 7 minutes. Using the rotational viscometer, record the 600 rpm and the 300 rpm readings until apparent viscosity, μA, which is theta 600 over 2, in other words, half of the viscometer reading measured at 600 rpm, reaches a value between 15 and 20. Measure the mud weight and 10-second gel strength of the sample when theta 600 over 2 reaches the above value. The 600 and 300 rpm viscometer readings are needed to calculate PV and YP. Next, estimate and record the amount of barite in grams that should be added to your mud to increase the density to 9.5 parts per gallon. Use the table named barite required to raise weight of 100 barrels of mud on page 25 of the lab manual. In the report, calculate the exact amount from first principle, in other words, using material balance. Add the estimated barite to your mud, an entirely new sample. Mix for 10 minutes and measure the mud weight. The mud weight should be very close to 9.5 ppg. Now, measure the 10-second gel strength. Then record the 300 and 600 rpm viscometer readings to calculate PV and YP. Use the mud retort to determine the low solids and high solids concentration. Apply the following procedure. A. Disassemble retort assembly. Fill sample cup almost level full of fluid to be tested. Put the sample cover back in place firmly, squeezing out the excess fluid to obtain the exact 10 cc volume required. Clean spill over from cover and threads. If threads are coated with silicone grease, it will prevent sticking. B. Lift the cover slightly and slide off so that fluid adhering to the bottom surface will be scraped back into the sample cup. C. To prevent boil over, fill the expansion chamber with steel wool. D. Select the correct heater assembly for the available voltage and screw into top of expansion chamber. Keep assembly upright so that mud does not slosh into the drain tube. E. Insert the drain tube into the hole at the end of the condenser, seating firmly. Percentage graduated cylinder should be clipped into place to catch condensate. F. Plug in the correct connector cord to the power supply and keep power on until distillation stops, which should occur in 15 to 25 minutes, depending on the characteristics of solid content and the atmosphere around the unit. G. Read the amount of water directly from the graduated cylinder. H. At the end of the test, grasp the rubber-covered connector just above the heater and separate the retort assembly from the condenser. Handling the hot retort by means of the connector cord, dip in water to cool. The plug is waterproof and may be immersed completely. I. Most of the solids remaining in the retort will adhere to the heater where removal is easy. Use a spatula to scrape out the cup and expansion chamber. Run a short length of pipe cleaner through the condenser hole and retort drain tube to remove oil residue. J. The specific gravity of mud solids can be obtained by the following formulas. All percentages are volume percentages. Now, enter Figure 1, which is on page 32 of the lab manual, from y-axis with specific gravity of solids, and read the weight percentage of high gravity solids and calculate the weight percentage of low gravity solids. 100 minus weight percent of high gravity solids. After the lab has been completed, here are some topics you should think about and create answers for. 1. Discuss the effect of adding barite on drilling fluid properties measured. 2. Discuss your results from retort analysis. In other words, compare your retort analysis results and recorded barite and bentonite amounts obtained during the preparation of the 9.5 ppg mud. And 3. Solve the following field problem. To conclude the lab, there are some final questions you should answer. 1. Determine the total volume of mud in the system. In other words, the mud in the tank plus the mud in the well. 2. How many barrels of fluid must enter the well bore from the formation to increase the level of fluid in the mud tanks or pits by 2 inches? And 3. The long question seen on the screen now. Lab 3 is now concluded. Next lab we will learn about identification and treatment of salt-contaminated drilling fluids.